Hello, my lovely viewers. Let's take a quick look at this question. This question we are asked 25 cm cubed of 0.01 moles per dm cubed of tetraoxosulfacic acid neutralizes 25 cm cubed of sodium hydroxide, which is a base. The concentration of the base in moles per dm cubed is what? Neutralize, anytime you see neutralize like this, it means that it's coming from neutralization reaction, that is titration. All right. Now check the various values. Here we have 0.01 moles per dm cubed. Now there are some questions that I will give you in grams per dm cubed. Here is in moles per dm cubed, and we are also asked to calculate what? Moles per dm cubed. If you are given moles per dm cubed and you are asked to calculate moles per dm cubed, there is a formula for that. If you are given grams per dm cubed and you are asked to calculate moles per dm cubed, there is a formula for that. So for this one, we are going to use titration formula. All right, but before then, we are going to balance our equation. Tetraoxo written as, we say, solution. Tetraoxosulfacic acid is written as what? It's written as H2SO4. It says it reacts with what? It neutralizes what? Base. Look at it, neutralizes base sodium hydroxide, NaOH. This is a neutralization reaction which will give you what? Salt and water. So our salt is what? NaSO4 plus H2O. Now, of course, all of them are in aqueous form. Okay. Now, sodium here, let's look at whether this equation is balanced. Hydrogen here is what? Hydrogen is 1. Look at hydrogen here is what? 3. Hydrogen here is what? 2. So we need to add what? 2 here. If we add 2 here, it means that hydrogen is down 4. Hydrogen here is what? 3. So we need to do what? Add 2 here. Hydrogen here is 2. Hydrogen here is 2. Hydrogen here is 4. That 2 plus 2 give us what? 4. And hydrogen here is what? 4. It is balanced. We now come to sodium. Sodium here is 2. Sodium here is 1. We cannot come and add 2 here. Rather, we'll add 2 here because it's only sodium that carries this, to not sulfate. All right. So now, by this now, our equation is what? Is balanced. Now let's go to our formula. Our formula say is CaP is equals to Na over what? Nb. That is a formula we are going to use. When each time you see this kind of question, use this formula. All right, it's the simplest formula. Now the next thing you are going to do is that identify your parameters. Ca is concentration of acid. A here is acid. C here is concentration. So concentration of acid, look at 0.Ca is equals to what? 0.01. Volume of base is what? Look at. Now Va, volume of acid, look at. 15 cm cubed of this is acid. So we have what? 15. We now come to the concentration of base is equals to, say, concentration of base in, we are asked to calculate concentration of base, question mark. Volume of base is equals to what? We are given as what? 25. Are you following? Now the next thing is your mole ratio. Na. Mole ratio is what is outside here? Nothing. So it's 1:2. What is outside here in front of this sodium hydroxide? What is inside here is 2. It means that acid is 1, base is what? Base is 2. Are you following? So we now have is equals to 1, Nb is equals to what? 2. Now we are going to make this one subject of formula. So we say if you remove this one now, look at, if you remove this one now, you cross multiply. This one will go down, this one will go up. So we have what? CaVANB. You divide it by the one that is small, VBNA. That's how you are going to divide it. All right. So that is our CB. Having done that, let's put our parameter. CB now will be equal to C is what? 0.0 equals to multiply all this one, give us 0.3 divided by what? 25. So CB now will give us 0.012 moles per dm cubed. So our answer is what? 0.012. Do well to like, share, and comment.